Hello everyone. In this lecture we will discuss two basic rules of counting techniques. These rules are sum and product rules. So let us start with sum rule. Suppose we have a task T, or you can say event E, and suppose this task can be completed in either using say event E1 or say E2. You can assume these two different tasks also, or in the form of events also. So task T can be completed either using E1 event or using E2 event. Both the events cannot occur simultaneously. Means you can complete T using E1 only or using E2 only. And suppose E1 can occur in n ways and E2 can occur in m ways. Then the number of ways in which you can complete the task T, or in other words you can say, because this task T can be completed either using event E1 or using event E2. So you can say number of ways to complete the task T or E1 or E2. The number of ways to perform E1 or E2. This is given by n plus m. So this is the sum rule. Means if one event can occur in n ways, another event can occur in m ways, and you know that you cannot these two events cannot occur simultaneously, then the number of ways in which E1 or E2 can occur, this is given by n plus m. To understand this, let us take one example. Now suppose we have two buildings. One building is A, another building is B. Now suppose these are rooms in building A, 1, 2, 3, 4, 5. So in building A, rooms, there are 5 rooms. In building B, there are 3 rooms. So 5 rooms are there. 5 rooms are there in building A and 3 rooms are there in building B. So say this is, you can interpret in the form of E1. E1 means getting a room in building A, and this can be done in 5 ways. E2 getting a room in second building B, and this can be done in 3 ways. So m equal to 3, n equal to 5. So the problem is, if I have to find a room in either A or B, in either A or B. So how many ways are there to get a room in A or building B? So this will be given by 5 plus 3, this equal to 8. So we have 8 ways are there to get a room in A or B. Look at this here, this A. You can get a room either in A or in B. So you cannot get a room both in A and B. So that's why both these two events are these two events cannot occur simultaneously. So you will add these two numbers 5 and 3, so total ways equal to 8. So this is the sum rule. Now look at one example using this sum rule. In how many ways can we select a student's representative from 5 boys and 5 girls? So we have to select one representative. So this is the task to select a student representative. Now it may be boy, it may be a girl. So even suppose EB is for event of selecting a boy, or G is the event of selecting a girl. So either this can be done or this can be done. So EB, you can select a boy in 5 ways. Any boy out of 5 boys can be selected, and any girl out of 4 can be selected. So this is given by 4. So you can complete this task. You can select a representative using this one or using this one. So total number of ways, this is given by 5 plus 4, 9. So in this way you can apply the sum rule. Now product rule. Suppose you have a task T that can be performed using E1 and E2. Means this T can be performed using E1 and E2. Means both these E1 and E2 will be performed. And suppose E1 can occur in n ways and E2 can occur in m ways. For each of these n ways, look at this. For each of these n ways, suppose E2 can occur in m ways. So number of ways in which the task T can be completed, or E1 and E2 can be completed, this is given by n into m ways. So this is the product rule. Product rule means whenever for the first event, look at this, n ways are there, and for each of these n ways, this second event can be completed in m ways, then the total number of ways to complete this task, or E1 and E2, this is given by n into m ways. Now to understand this one, again go to the example of this building. Suppose, look at this. This is the building A, and these are suppose now floors, 1 2 3 floors. So in this building, floors are 5, 1 2 3 4. So this one is say E1. Now in each floor there are 2 rooms. Look at this. In this floor, 2 rooms, 2 room, 2 room. In every floor there are 2 rooms. So number of rooms in each floor, this equal to 2. So if I have to get a room in this building, then how many ways are there to get a room? This is given by 5 into 2, this equal to 10. So 10 ways are there to get a room in this building. So look at this here. For this first one, for each of these 5 cases, here 2 ways are there. For the second one means getting a room. First one is the getting a floor, second one is getting a room in each floor. So total number of ways, this is given by 10. So this is the product rule. Now look at this. Now if you consider the building like this, where if you consider these first 2 floor, in first 2 floor 3 rooms are there, and in last 2 floors 2 rooms are there. So we cannot apply product rule directly, means you cannot write 4 into 2 equal to 8. 8 ways are there to get a room in this building, because for each of these 4 ways, look at this, in first 2 floors 3 rooms are there, and last 2 floors 2 rooms are there. So you cannot say that for each of these floor equal number of rooms are there in this building, because for first 2 this number is different, and for last 2 this number is different. So what we will do? So we'll assume this one is different from this one. Say this one is E1, getting a room in E1 in first 2 floors is different from getting a room in last 2 floors, E1 and E2. So here we have to do either in first 2 floors or in last 2 floors. So first you will apply some rule, either E1 or E2, because look at this, you will get a room either in first 2 floors or in last 2 floors. So this can be done in E1 or E2, that is E1 plus E2. So here we will add the number of ways for E1 and E2. Now for E1, how many ways are there? Now for each of these floors 3 rooms are there. So then you will apply the product rule. For each of, so 2 floors are there, and each floor 3 rooms are there. So total number of ways 2 into 3. Now plus for E2, 2 floors are there, and in each floor 2 rooms are there. So 2. So this is given by 6 plus 4. So in all 10 ways are there. So in this way, there is a basically combination of product and sum rule. So you have to be very careful. These rules are very simple, but you will see these 2 rules have tremendous applications in finding solutions of various counting problems. So you must be careful whenever you have to use a product rule and whenever you have to use a sum rule. Look at this an example. Here we have used both of the rules, because for each of this first event, the second event, number of ways are not equal. If these are equal, then you can apply directly product rule. But if these are not equal, then you have to break it. You have to break it into 2 parts or 3 parts as per the requirement, so that the condition of product rule is satisfied. So this is product rule. Now look at this example. In how many ways can a group of 4 students select a president and a secretary if no student can be selected to more than 1 post? Now look at this. We have to select 2 positions. One is president, another is secretary, and 4 students are there, say S1, S2, S3 and S4. So 4 students are there, and we have to select these two positions, president and secretary, and condition is no student can be elected more than one post. So for president, how many choices are there? Look at this. If we have to select a president, then 4 choices are there. So number of ways for this one is given by 4. Now look at this. If no student can elect it more than one, means we have already selected one student. So remaining choices for secretary will be only 3 students. So for this post, we have only 3 choices. 3 choices. Now the problem, whether to apply product rule or whether to apply sum rule. Now look at this. If you see, suppose in first place we select S1. So for S1 we have 3 choices for the secretary, that is S2, S3 and S4. Similarly, if you choose president as S2, then again we have 3 choices, S1, S3 and S4. Similarly, you can write 3 choices for S3 and S4 also. It means for each of this process or this event, we have 3 choices for the selection of secretary. That's why we will apply product rule. So total number of ways so that we can select president and secretary, this is given by 12. So you can count also. You can write it S1, S2, S1, S3, S1, S4. Similarly, S2, S3, S2, S1, S2, S3, S2, S4 and so on. So total number of ways equal to 12. Now, how many different 3 digits number can be formed by using the digits 1, 2, 3 and 4 when repetition is not allowed and second repetition is allowed? Now look at this 3 digits number. It means suppose this is a 3 digit number. Just take the first case A when repetition is not allowed. So first place we have 4 choices. To fill this first place you can use 1, 2, 3 and 4. So for first place you have 4 choices. Now if repetition is not allowed, it means you have consumed one number. So for second place you have only 3 choices, and for the last place you have only 2 choices. Now what to do, whether to apply product rule or sum rule? Look at this. For each of these 4 ways you have 3 choices for the second place. Similarly, for all these choices again you have 2 choices for each of these choices. So you will apply product rule. So this is 24. So total number of ways equal to 24. If repetition is allowed means for first place you have 4 choices, and repetition is allowed, again you have 4 choices, again you have 4 choices. So 64. So total number of ways equal to 64. So in this way you have to check whether given repetition is allowed or not. In case suppose these two conditions are not given, only this problem is given, how many different 3 digit numbers can be formed using the digit 1, 2, 3 and 4. Only this part is given, and suppose this A and B are not given. So what to do? Now if no condition is given, look at this the problem. 3 digit number. 3 digit number means it may be 1, 1, 1 or 2, 2, 2. So it means the problem is repetition is allowed. So you have to check the problem whether you can repeat a number or not. Now suppose we insert another number 0 in this. The problem is same, how many different 3 digit numbers can be formed using the digits 0, 1, 2, 3 and 4. Repetition is allowed and second repetition is not allowed, but here we have inserted 0 also. Now what is the change when we insert 0 here in this set? Look at this. The first case, when repetition is not allowed, we have to make a 3 digit number. Now look at this. For first place we have only 1, 2, 3 and 4, that is 4 choices. You cannot start the first digit with 0, because if you start with 0 then this will become a 2 digit number. We need a 3 digit number, so it means you cannot start with 0. So for first place we have actually 4 choices only out of 1, 2, 3 and 4. Now look at this. Here one number is already consumed from 1, 2, 3, 4. So now for the second place you can use 0. So the remaining number 3 from this set, 1 from this. Again we have 4 choices for the second place. Now we have consumed one number here, one here. It means we have consumed 2 numbers out of 5 numbers. So remaining choices for this third place is 3. So now look at this. We will apply the product rule, because for each of these choice we have 4 choices in second place. Similarly, for each of these choices we have 3 choices in third place. So we will apply this product rule. So in all we have 48 ways. 4 into 4 into 3. Now second one, when repetition is allowed. When repetition is allowed, look at this. Again you cannot fill the first place with 0, so you have only 4 choices. But for the second one you can choose any one out of these 5. So for 5, again for last one this is 5, and you will apply the product rule. So this is given by 100. So 100 ways are there, or 100 3-digit numbers can be formed if repetition is allowed. If repetition is not allowed, 48 different 3-digit numbers can be formed. Now another interesting problem. How many 3-digit even numbers? Now we are talking about even number. The set is 1, 2, 3 and 4. So again the repetition is not allowed, repetition is allowed. So even number means now there is a 3-digit number. Even number means now the restriction is there for this last place. So first we have to check the number of ways for this place. Even number means you can fill this place using 2 or using 4. So only 2 choices are there for this place. So number of choices, number of ways for this place is 2 only. Now start with this one. So one number is consumed here. Repetition is not allowed. It means for this place you have 3 choices. Now 2 numbers are consumed. So for this place you have only 2 choices. So total number of ways is given by, again we will apply the product rule as we have discussed earlier. So 3 into 2, 6. This is given by 12 ways. Now B part, when repetition is allowed. Again you will start with this one. So 2 choices are there for this one, because you can write it 2 or you can write it 4 as even number is required. Now for this place you can write any one out of 4. So 4. Again for this one you have 4 choices. So 4 into 4 into 2. This is 32. So 32 ways are there. So in this way you can count 3-digit even numbers. Now look at this problem. Here again we have to find 3-digit even numbers, but here I have included 0 also. 0, 1, 2, 3 and 4. 2 cases are same. Repetition is not allowed, repetition is allowed. So we'll start with first case when repetition is not allowed. So 3-digit number. Now look at this. For the last place we have basically 3 choices. You can fill it with 0, 2 or 4. But one interesting thing is there which you have to note down. That is, for each of the choices we do not have the equal number of choices for first place. How? Look at this. Suppose you fill the last place. Suppose these 3 places are there and you fill the last place with 0. So it means only one choice is there for the last place. You have filled it with 0. Now for the first place, look at this. Now the remaining numbers are 1, 2, 3 and 4. So it means you have 4 choices for this place. Now for this second place, we have already consumed 2 numbers. We have 3 choices. So total number of choices is equal to 12. But suppose if you fill the last place with suppose 2, means for the last place we have only one choice. We have filled it using 2. Now for the first place, look at this. We have filled this number with 2. It means for first place the remaining numbers are 0, 1, 3 and 4. But you cannot fill this place using 0 because it will become a 2-digit number. It means for the first place, when we fill the last place with 2, for the first place we have only 3 choices. We can utilize number 1, 3 and 4. So for this place we have only 3 choices. We have consumed two numbers, one here and one here. So for this place again we have only 3 choices. So this is given by 9. Similarly, if we fill the last place with 4, so how many choices are there? Look at this, count it. For last place we have only one choice as we have written 4. Similarly, for this first place, now we have utilized this 4. For the first place we have 0, 1, 2, 3 and we cannot write 0. It means only 3 choices are there for first place. And as we have consumed 2 numbers, so again we have 3 choices for the second place. So total choices are 9. So look at this. If you fill the last place with 0, so number of ways for this is 4. But if you fill with 2 or 4, then number of choices are same, 3 and 3. So if you go back, look at this, the last example which I have shown here, which I have given. Look at this. If you see this case, in first 2 floors, number of rooms are equal, but in last number of rooms in first 2 floors are 3, but in last 2 floors number of rooms were 2 only. So we have calculated these separately, means we have used this sum rule also. So first we have calculated for E1, then we have calculated for E2. So this is a similar problem. It means if you see this problem, if you fill the last place with 0, then we have 4 choices. It means you will count it separately. That is, say this is E1 when we fill the last place with 0, and this is given by 4 into 3 into 1, that is 12 ways. For E1 we have 12 ways. Now for E2 you can combine these two, because for each of the choice 2 or 4, number of ways are equal in these two places. So you can count it in this way. Either you add these two or simply multiply 9 with 2. So for E2 you have 9 into 2, that is 18 ways. You can directly count these two, that is last place can be filled in 2 ways, either 2 or 4. And for this we have 3 choices for first place and 3 choices for second. So in this way that 18 ways. There is the sum of basically these two if you count separately. So directly you can write it 2 ways here. So in this way you will get 18 ways. So now you have 2 events, E1 or E2. Either you can fill this last place with 0 or you can fill it with 2 or 4. So the total number of ways will be given by E1 or E2. So this is in how many ways? 3 different digit even numbers can be formed using these digits, can be given by 12 plus 18. This is 30. So total number of ways equal to 30. So in this way you have to apply some reasoning before solving a problem, because in each problem you will it is not the case that for each of these places you will have the equal number of ways for the first place or second place. So you have to be very careful while applying the sum and product rule. So I hope that you got the concept of sum and product rule.